let's classify some data. So when we're conducting a study, it's important to know what kind of data is involved. A lot of times with studies, especially as they get larger, you're going to have a bunch of different types of data all within the same data set. My graduate program is data analytics, and I'm usually dealing with data sets that have maybe 30 different variables, all a mix of quantitative and qualitative data. So being able to look at the types of data and kind of get an idea for what those expected values are. Based on the type of data, that will determine how you can classify and quantify and use and display that data. So we have two types, two main types. We have qualitative and quantitative, okay? Qualitative data consists of attributes, labels, non-numerical entries, okay? Names of things, okay? Qualitative data is names of things, attributes, labels, non-numerical entries. Quantitative data is numbers that are measurements and counts, okay? They have to be measurements and counts. You want to be careful because sometimes we have data that is numbers, but the numbers are representative of something else, okay? And they're not a count or a measurement of something. And so quantitative data is numbers that are measurements and counts. Another terms for these, qualitative is considered categorical data, okay? Categorical, and quantitative is numerical. Okay. And another way to think of it, so quantitative has that N in there. N for numbers. N is numerical. While qualitative has that L, an L as in a list of things. Okay? So that qualitative data is a list of things. The quantitative data is counts and measurements. So we can look at data sets, and data sets can have a mix of quantitative and qualitative data in them. So when we're looking at the vulnerable, endangered, and critically endangered species chart, what data is qualitative and which data is quantitative? Yep, these are all of our qualitative because we have a list of things, and these are our quantitative because they are numerical counts. And qualitative lists and quantitative numerical counts. And then what we can do is we can actually break up qualitative and quantitative even more, okay? So starting with quantitative, okay? When we have quantitative data, we have lists and counts. We have two types of counts. We have discrete data and we have continuous data. Discrete means that the number of values is finite or countable. Right? And that means that, for example, flip of a coin, okay, or the tosses of a flip of a coin. I can flip the coin once, I can flip the coin twice, I can flip it 3 times. I cannot flip it 3.5 times. I can't flip it 4 3/4 times. It has to be a discrete integer value. Now, it doesn't have to be integers for discrete. We have other levels of measurement, but there's an end to where the value can be. Okay? It has to be countable. So I can flip a coin in any number of whole times, but I can't do it part of a time. Continuous data is infinite. Okay? A lot of times, easiest thing to think about is like lengths, temperature, time. I can have a minute. I can have 1.1 minute. I could have 1.11 minute. I could have 1.11111 minute. I can keep breaking down and extending that decimal further and further and further and further. That is continuous. I can measure it with increasing accuracy. If I got better and better tools, I could continue to measure it infinitely where it is no longer countable. Okay? Most of the time, not always, but most of the time, we're looking at length, we're looking at time, and we're looking at time. Well, not always. So, let's look through each of these lists, these values, and we want to determine whether it is qualitative or quantitative data. And if it's quantitative, we want to identify it as being discrete or continuous. Okay? So let's start with student identification numbers.
Quantitative.
Why do you say quantitative?
The number.
Is it counting something? Qualitative. Student identification numbers represent what?
A person.
Represent a person. So your number could be a replacement for your name, right? It's not counting anything. So even though it's a number, it's not counting the number of students. It's applying a numerical label to the student. Therefore, it is qualitative. It's a numerical label. Another thing similarly, a number on the back of a basketball jersey. Those numbers don't count anything. It's not counting the number of players. It's assigning a numerical label to that player. Does that make sense? So for quantitative, it needs to be a count or a measurement. So you got to think really carefully about that. Just because it's a number doesn't mean it is quantitative. The rolls of a pair of dice. It's quantitative. We can roll it once, we can roll it twice, we can roll it 3 times. Now, is that going to be discrete or continuous? Discrete. Can I roll it 3.5 times? No, it has to be at whole integer value. So we've got quantitative, and it will be discrete. A list ranking the universities and colleges in Florida. Qualitative. It's right there. It's on the list. Qualitative data. The heights of the Montverde girls basketball team. Quantitative. Okay, because we're measuring height. It's a measurement. Is it going to be discrete or continuous?
Continuous.
Who wants to defend their reasoning for discrete or continuous? Why do you think? Yeah, we could keep going, right? If I got a ruler that had finer and finer measurements on it, okay, or if I got some way to measure using lasers or whatever, I could continue with more and more accuracy to get more and more specific values of exactly how tall they are. It's continuous. The shoe sizes of the Montverde varsity boys basketball team. It's definitely quantitative, but it is not continuous. Anyone tell me why it's not continuous? Think about it. Shoe sizes. I didn't say foot length.
You could have half.
But shoe sizes. You could have 10. You can have 10 and a half, but you can't have a 10 and a quarter shoe, right? You don't have a 10 and an eighth shoe. There's limits set on it because it's an arbitrary standard. You can have a shoe size of 10, 10 and a half, or 11, but nothing in between. So it's discrete. If I said the length of the foot, that would be continuous. But the shoe size, that's defined and discrete. The home countries of Montfort students. Quantitative or qualitative? Okay. All right. Good. All right. Now we've got levels of measurement. Okay, 4 levels of measurement. The first is nominal. Nominal as in names. It only applies to qualitative data. So if we have quantitative data, we know it's not going to be nominal. It only applies to qualitative data. So when we have categorized using names or labels or qualities, and what it breaks down to is there's no mathematical computation that can be made. Okay, I can't compare red and blue. I can't compare yes and no. It's qualitative data that I cannot compare mathematically. So I have survey responses of yes, no, or undecided. That's nominal data. It's qualitative, and there's no mathematical comparison that can be done. Versus ordinal. Ordinal can be qualitative or quantitative. The difference is that the data can be arranged in an order or it can be ranked. So we could have qualitative data, but there's a ranking to it or an order to it, and that makes it ordinal. So there is a difference between data entries, but there's not a mathematical difference. So the mathematical difference doesn't matter, but we can rank it, we can order it. So I've got an example there, course grades, A, B, C, D, and F. Okay? That is qualitative data. That is a list of things. But they have an inherent rank in them that an A is a higher grade than a B, which is a higher grade than a C, which is a higher grade than a D, and so on. So there's an inherent rank in this qualitative list. So for these two data sets, we want to determine whether it is nominal or ordinal. Okay? So for number 1, take a look at that and tell me whether you think it's nominal or ordinal and why. Why do you say ordinal? Yeah, it's a ranking. The main difference between nominal and ordinal is, can it be ranked or can it be ordered? Ordinal means order. You put it in an order. Since it's saying the top 5 with the most growth, it's a ranking. Therefore, it's ordinal. What about number 2? Why?
Because there's no number.
Right. There's no ranking or order that goes with movie genres. There's just genres. Okay? You may have a favorite, but that doesn't put it in order. Not on its own. So ordinal versus nominal. Both qualitative data sets, but one has an inherent rank to it, the other one doesn't. The next 2 levels of measurement we have are interval and ratio. So these are going to be quantitative data only. Quantitative data only. Interval and ratio. They have to be numerical. Okay? Quantitative data. So on the interval, we have quantitative data And the data can be ordered, so we're kind of adding to that ordinal value. We've got something that's ordinal, but now we have meaningful differences between data entries. Okay? We can do a meaningful mathematical computation between the data values. Okay, so that's that next step. But the big thing that differentiates it between interval and ratio is this last one. 0 represents a position on a scale, not none. Ratio is pretty much all that same stuff, but 0 represents none. Okay? So to determine the big key between interval and ratio is looking at 0. Is 0 a position on the scale, like in years? The year 0 doesn't mean there was no time. It wasn't time none. It was just a time between one calendar and the next. That would be interval. But if 0 means nothing, the amount of time left in class, 0 minutes, that means that time is over. Class is done. Okay? So if 0 is a position and doesn't mean none, it's interval. If 0 means nothing, it is nothing, then we're at a ratio. We can also create ratios with the values that can be formed. And then we can also express data values as multiples of another when we're looking at ratios. So we've got 2 data sets. We've got the New York Yankees World Series victories, and then we've got the number of American League home runs, and want to determine whether it's going to be interval or ratio value. So which of those do you think contains an interval and which one is a ratio? So the years for the interval, why? Okay, so because it's number of years, interval. And there's a meaningful difference, okay? And this is the part where we're going from ordinal to interval, is there's a meaningful difference between the years. If I were to take those first 2 years and I subtract them, there's a meaningful difference. 4 years between victories. There's a meaningful difference between the values. And then I look at the next 2 and say there was 1 year between victories, and then 4 years between victories, and then 4 years between victories. So there's a meaningful difference. So that's how we know that it's interval and not ordinal. And how we know it's interval and not ratio is that 0 doesn't imply none. What about with the second list, the number of home runs? How do we know it's ratio and not interval? Say none what? No home runs. 0 means no home runs. 0 means there are no home runs. And then we could also do other computations. There's a meaningful difference between the difference. Boston got 4 more home runs than Baltimore. Chicago got 17 more or 15 more home runs than Boston. Sorry, doing that backwards. Okay, there's a meaningful difference. We can also do ratios, and if there was a team that only scored 40, we could say that Tampa Bay scored twice as many home runs as another. So there's these ratio values and multiplications that can happen when we're doing comparisons. Okay, so those are all the different ways we can identify ratio. So as we're going up these lists, it's basically becoming we can do more and more math with them. The more math we can do with the values, the further down the list we're going, from nominal to ordinal to interval to ratio. Notice how each one is kind of building on the previous. Nominal all the way at the top. Ordinal, now we can arrange it in order. Interval, now we can order it and there's a meaningful difference between the values. Now we can order it and there's a meaningful difference, and 0 means there's nothing. Okay, so we're building on nominal to ordinal to interval to ratio. All right? So we want to classify each type as nominal, ordinal, interval, or ratio. Cost of a cheeseburger. Why do you say nominal? Okay.
And make like rankings on like most expensive.
Okay. Go
Go
ahead.
You might be ratio because
0 has a meaning of none. It's ratio. So, again, we're going with level of specificity. Yes, we can order it. We can rank the cost of the cheeseburgers. Okay? That puts it at ordinal, but there's a meaningful difference in the price. This cheeseburger is $1 more than the other one. That moves it down to the interval. And if it was $0, it's free. That moves it all the way down to the ratio level. So be very, very careful because a lot of these things, notice, data can be ordered right here. Actually highlight. Data can be ordered. Data can be ordered. Similar to the interval level, meaning data can be ordered. That's true. That fact is true for 3 of those categories. Then we have to look at and what else, and what else, and what else, until we hone all the way down to where it's as far as we can go. Brand of shoe. Nominal. There's no order to it. It's quantitative, so it has to be, or qualitative, it has to be one of the first two. The temperature outside is what?
frightful.
It is frightful. But what level of measurement is it? Why?
Because it could be 0 degrees, but it goes.
0 is a position on the scale. 0 degrees does not imply no temperature, except on the Kelvin scale.
The
Kelvin scale is the only one where temperature means absence of heat at 0. So, but on every other scale, it is interval. Except the Kelvin scale. But absolute 0 is unobtainable. Except the Kelvin scale. Movie ratings. Like PG, PG-13, G. Or even movie ratings as far as 1 star, 2 star, 3 star, 4 star.
I think it's
Wow. Great. There's no meaningful difference between the ratings. Ordinal. Number of questions on a homework assignment.
8.
Why?
You have 0.
And then you have no homework. If you've got 0 problems, there's no homework. The time Valentina arrives at school. It's different every day.
Oh, nice. I'm so mad at
I already told her to put it in there. Why? Okay, yeah, there's a meaningful difference. And the time was 0, that would just mean she got here at midnight. Kind of weird, but you know. What you got to do? We got interval. There's a meaningful difference between the values, but 0 does not imply none. Time spent working on homework. Why?
It's
0 minutes.
less.
So when you're looking at deciding what level of measurement it is, you're kind of building on it. Can I order it? If not, you're right there at the top at nominal. There's no order to it, it's nominal. If you can, now you move down to ordinal. Then you have to ask yourself, okay, I can order the values. Is there a meaningful difference between them? If so, then you move down to interval. If not, you stay right there at ordinal. Then you ask yourself, okay, I can order it, and there's a meaningful difference between the values. Does 0 imply none? If 0 implies none, then you move right down to ratio, and that's your level of measurement. But if not, you stay right there at interval. So we're adding to each of the levels through our classification. All right. Questions, comments, concerns, queries, or cool. Types of measurements.